Okay, here we've got a graph sketching question. Both of these are factorized for us, which is kind of them. We need to detect what kind of graph they are. If I multiplied this out, I would have some x squareds. Okay, it would be a negative number of x squareds. So it's a quadratic graph, and the things you think about on a quadratic graph are the shape, which way up is it? You think about the y-intercept, you think about the x-intercepts, okay, and sometimes you need to think about the vertex point as well. What does it ask us to do? It wants the coordinates of the points where the graph crosses the coordinate axes. Doesn't mention the vertex. We've had that on a previous question, so I think these three things will be enough. So the y-intercept is when x is 0, so substitute x equals 0 into that. The x-intercepts are when y equals 0, so if we solve this equal to 0, it's already factorized for us, so we should be able to get two values for x. Okay, same kind of thing on the cubic. Okay, no such thing as a vertex here, but once again we have a shape, so think about how many x cubed. Okay, what kind of shape is it going to be? We know from experience it's more likely to be one of these shapes than it is to be one of these shapes. Okay, to find the y-intercept, do the same thing, substitute x equals 0, and to find the x-intercept, we're going to solve this equals 0. There's going to be one value from this bracket, and there's going to be a repeated value from this bracket, and we know at a repeated root, okay, the graph just touches the x-axis and moves away again, so it's going to do something like either that or like that, depending on which way round it's going, okay, and it's going to be doing that for the value of x that makes this 0. Okay, so make sure your sketch shows that clearly. Okay, so that this point here or here must be one of these points on your graph. Then in part B, we've got to show that the x-coordinates of these are given by the points of intersection. That's a trigger phrase. Okay, intersection means we're solving simultaneous equations. Oh, look, they tell us the two equations. So we've got y equals, so these two things have to equal each other, and we need to rearrange that to get this equation here. Okay. Then for the last part, we now know that the point A lies on both of the curves, so that means it is one of these points of intersection, and the x and y coordinates are both positive. So we know that, with the help from part B, that this equation is true at A. So we need to find the solutions of this. So either this first factor will equal 0, or this second factor, this quadratic, will equal 0. So in fact there are going to be three values of x that are all possibilities. To choose the correct one, x and y coordinates of A are both positive. Well, positive means greater than 0, so if you get any zeros here or anything that's negative, you can throw them away. You may need to find out the y coordinates before you can decide the third one. Okay, so we may need to substitute the y coordinates back into one of the graphs to find the appropriate value. That one looks like the easier graph to me. Okay. And look, the answers have got root 3's in. So that's a bit of a clue. If the answers are going to be having square roots of 3's in, then some of these solutions are going to be surds, which means that when you're solving this quadratic, when you're finding when that equals 0, it's probably not going to factorize. So that's a clue that you're going to have to use the formula, or if you really like completing the square, solve by completing the square or the formula. Okay, so that's what's going to happen. So quite a bit going on, and it is worth 7 marks, so make sure you do that accurately.